We're going to go through some actual error codes that you'll see on the drive. These are our codes that are going to pop up. We'll kind of go through what they mean, how you would troubleshoot them. All right, so the first one is going to be base block. This actually is not an error. It's more of a status indication. Usually it accompanies an error. So the base block just means that the output transistors, the IGBTs, they're not firing. They've been turned off. So usually this will happen with a fault. The fault will happen, and then you'll get a BBL along with it. So if you see a BBL in the fault log, look at what came earlier. That's probably the actual fault that caused it. All right, error over voltage, E.OP. This means that the DC bus has gotten too high, and the drive faulted out to protect itself. Have you guys seen this before, over voltage? And what was the issue in your situation?
We were having voltage issues in the incoming power.
Okay, so he was having some incoming power issues.
And we see it a lot on generators when they transfer generator power.
Yes, so a lot of times incoming power, especially if you're using a generator, that can cause an over voltage. So that is one of the things that we can check. A quick note for the 60 volt drives, 840 volts DC, that's going to be the limit at which the E.OP triggers. And then for the low voltage, the 230 units, it's going to be at 400 volts DC. This level is not adjustable. We can't change this. Again, this is for protection of the drive. So a few things to look at. One of the first things is, yes, incoming power. If you have a spike on the incoming power, if it is large enough, that will be reflected in the DC bus. So always making sure that incoming power is consistent. Another thing to check with incoming power is that your phases are balanced. If you have an imbalanced phase, that could also cause some issues here. Our threshold for our drive, what we recommend is 2%. So your phase to phase, you should not be any more than 2% difference. So for a 460 volt drive, that's approximately 8 to 10 volts. Anything that is above that, you could have some potential issues there. Another thing with the E.OP to look at is, are you using braking resistors or are you using a regen? Because troubleshooting is going to be different there. I'll start out with the braking resistors, just because that's the more simple application. But braking resistors, one thing you can check there is the actual resistance of the resistor. So making sure that it is what it's supposed to be. It's at the appropriate level. Making sure that it's sized correctly. That's another one. Typically, the controller manufacturers will size them for you. I have seen on a number of applications, though, that the sizing may line up, but due to XL rates, decel rates, jerk rates, that type of thing, you may need to bump up a different size resistor. So that is one thing to look at. To kind of see if it could be a potential sizing issue, is what you can do is play with the XL rates. So try decreasing your XL and decel rates and see if the problem is still there or if it goes away. If it goes away, then it's likely it could be something with the size of the resistor that may need to be looked at. If you're getting it regardless, then it maybe could be that the resistor itself is bad, or the drive itself, the braking transistor, could be faulty. So the braking transistor, that's going to be on the plus and the PB terminals. That's where your braking resistor should be connected. Do not connect the braking resistor to the plus and minus. That is a direct connection to the DC bus. You will burn out your resistors. The braking transistor is going to kick on at 760 volts DC for the high voltage, and at 380 for the low voltage. So this is the level at which the braking transistor will open, and extra DC bus voltage should be going across the resistor. To check to see if the braking transistor is opening and closing when it should be, you can look at a diagnostic screen number 1, look at your DC bus voltage, and see if when it reaches those thresholds, if you see a drop or a dip, or if it continues to increase. If it continues to increase, it's likely indicating there's something going on with the transistor or the resistor itself. We'll also go through a few hardware checks later on for how to check to see if your braking transistor is bad, along with incoming rectifier and outgoing IGBTs a little later on. So we'll do some more hands-on work. So if you're using a regen unit now instead, troubleshooting is going to be a little bit different, and the E.OP is more of a symptom of a different problem than ultimately than just the strict overvoltage. So if you're using a regen, it basically means that for some reason your regen is not taking that extra DC bus voltage, putting it back onto the line. So we need to move towards the regen side of things. The regen is going to start regenerating at a much lower threshold than what the braking transistor would turn on. So what happens is when you power up the regen and the F5, the regen will calculate the idle DC bus voltage. It'll add 3% to that, and that's what when the regen will start modulating back to the line. So that 103% of idle DC bus voltage is lower than what the braking transistor would turn on at. And again, for regen, you're not connected to the braking transistor, so we don't have to look at that at all. I have a section on the regen as far as troubleshooting, things to look at there, so we'll cover regen troubleshooting later on. But if you are using a regen, you're getting the E.OP, it's likely that the regen is the ultimate cause. You've checked the regen. If you're using a braking resistor, you've checked that. A few other things that it could be, if those weren't your issues. Could be the voltage spikes from the line. Again, we've seen incoming power. If the spikes are severe enough, that could be the cause of it, especially during generator operation, where the power might not be as clean. That's definitely something to look at there. It could also be due to just a higher line voltage. In some applications, the supply voltage is just at a much higher level, above 500 volts. Our drives are rated to 520 volts AC, but again, if you're sitting at a higher voltage already and you have any more spikes, those spikes are going to be reflected in the DC bus compared to if you started out at, say, 460 or 480. So if you're at a higher voltage, and even if you get a smaller spike, that's what could be the cause. One other thing to look at as well is the DC bus measurement circuit, making sure that the drive is measuring the DC bus correctly. If you remember, look at diagnostic screen number 1 and take your meter, verify against your incoming phase-to-phase voltage. The DC bus should be sitting at approximately 1.41 times incoming phase-to-phase. Another thing you can check is the actual DC bus itself with your meter. You want to make sure that your meter has the capability to go up over 600 volts DC, but you can measure across the plus and minus terminals and verify that it's roughly the same as what the drive is calculating. If there's a significant difference, or if the drive is reading 0, then you know that there's an issue with the measurement circuit on the drive. In rare situations, I have seen it where it's due to noise. It's kind of a caveat here, noise can potentially cause anything really, but in this situation, the one that I was working on, the motor was not grounded. For whatever reason, they just did not hook up the ground wire of the motor. And it was happening at the exact same time in the profile. It seemed to be right when we were rolling over from XL into constant speed is when we'd get this E.OP. Again, we looked at resistor, we looked at incoming power, everything was fine, and we just kind of followed it back to the motor, no ground wire connected. Hooked it up, problem went away. So noise can be a cause of this. Grounding, just as a whole, grounding is very important, but specifically for this one, that could be the cause. All right, E.UP, under voltage. It's just the opposite of an over voltage, means your DC bus is too low. This one usually is due to line side issues. And where we mostly see that is using a generator. It seems that when you make the switch over, for whatever reason, the generator may have issues keeping up, can't supply the right voltage, so that could be an issue. The thresholds for the high voltage 460 units is going to be 240, and then for the low it's going to be 216 volts DC. Troubleshooting is much the same as with the over voltage. You're going to want to verify that your DC bus is reading correctly with a meter, and on the drive, verifying against your incoming phase-to-phase voltage. One thing to check as well is if you're using an isolation transformer. They should have an XO or an X0 terminal on them. That needs to be grounded. It needs to be grounded to an earth ground. If that is not grounded, again, noise. That can also cause this. So the XO terminal on an isolation transformer needs to be grounded. As a note, the 460 volt drives can be used on single phase 230, but we need to program an input for that. If you are using a battery backup system and you'd like to use this function, the input needs to be programmed for that. We'll talk about that in the input section, but if you're getting this error when you're switching over to emergency power, if you don't have your input set correctly, that could also be the cause of this. All right, E.OC, error overcurrent. This means that there is a short or a ground fault somewhere, either on the drive or motor side of things. So if you've ruled out everything on the motor side is fine, a couple of things that could be the cause, drive side, or if you're wondering, is it the drive or is it the motor? The quickest way to figure that out is going to be disconnecting the motor leads from the motor contactor and then trying to run. If the E.OC, if you don't get it after you disconnect the motor leads from the contactor, then it's something on the motor side to look at. If you are still getting the error after the motor leads have been disconnected, that means that the short is going to be in the drive itself. So that's a really quick test to see, okay, hey, do I need to look at my motor? Do I need to look at my drive? A few other things that you can do, bypass the motor contactor to see if it's the contactor itself. On a number of applications I have seen where corroded contacts have actually caused that. Could be the contactor timing, usually less of an issue, but if you completely bypass the contactor, that should rule that out. If it is on the drive side of things, we have a hardware check, a diode check that you can perform with your multimeter, and again, we'll go through that on how to troubleshoot that. But if you've ruled out the motor, that's not the cause, and it's due to the drive, then that is something that would have to come back to KEB, and we'd have to look at. The next one, E.OL, error overload. This is going to be a high current for a set amount of time, and it's going to vary depending upon the size of the drive. So on the left here, less than size 24, when we draw 150% of rated current for 30 seconds, is when you would the E.OL would be triggered. If you compare that to the larger size drives, it's going to be 120% for 30 seconds. E.OL2, error overload, low speed. This is again high current, but at low speed or low frequency. Specifically, it's going to be below 3 hertz. The range that you're going to be in, that's 150% here, below 3 hertz. That's going to be the E.OL2 range. You're going to see this on permanent magnet applications. Anything to the left side of this curve here, you're going to be in the E.OL. So anything above this 3 hertz. Error motor protection. So if you have this function activated in the drive, you may get this. This is a motor protection function that is used, and you can set the amount of current that you wish to kind of set your threshold at. And again, this is just going to be dictated by a curve, and depending upon what you have your your percent of motor current set to in the drive is going to dictate when you get this E.OH2 error. And again, this function is activated. If you wish to disengage it, you can. All right, so the E.OL, E.OL2, E.OH2, what it all boils down to is high current. You know, there are slight variations of when you're getting the high current, whether it be the low frequency with the E.OL2, or if the motor protection is activated. At the end of the day, it's high current. So how we troubleshoot that is just with high current. So in a high current situation, you know, we go back to mechanical issues. Is our brake picking? For permanent magnet motors, is our encoder communicating correctly? Do we have the correct encoder position? If we have an induction machine, if we put it into open loop, do we still get this error? That type of thing. Error overheat, this is going to be the heatsink itself is too hot. The transistors, they may have switched the carrier frequency down to take care of that, and you might start hearing that switching frequency. But yeah, the heatsink, it's too hot. A few notes on this. We do have fans internal to the drive, and they should be coming on at 45 degrees Celsius. If they're one way you can test that is actually go to the special functions parameter group in the drive, and if you go to LX06, turn that to on, the fans should come on if they aren't already on. That way you can tell if it's just due to the fans not turning on, or if there's maybe something else going on. The fans should kick on when you function test. You'll be able to hear them and if you just put your hand on top of the heatsink, you should be able to feel a slight breeze. Another thing that you can look at if you're getting this error is the actual heatsink temperature. That should be on diagnostic screen number 7. And this you can kind of use, you know, verify just kind of with your hand. You know, use common sense. Say, hey, you know, what does diagnostic screen number 7 say? If it says 150 degrees Celsius and you put your hand on the heatsink and it's cool to the touch, well, okay, there's an issue with the measurement circuit in the drive. So that's something that you can do as well. Or if you actually have one of those infrared thermometers, and if you wish, you could put it on the heatsink as well. Obviously, it might vary a little bit from where you're pointing it, but at least you can see if you're in the ballpark range. All right, E.bus, abnormal bus stop. So this is going to be a serial communication error, and it could be a number of places. It could be in between the keypad and the drive, or it could be between the keypad and the controller if you're running serial speed control. So troubleshooting this, you want to see, you know, where is it occurring. So if you're running serial speed control with the controller, one thing you can do is switch the type of speed control in the drive. So switch it to binary or digital. Are you still getting the abnormal bus stop? If it goes away, it's likely due to a communication issue between the keypad and the controller. The baud rate needs to be set correctly, both in the controller and in the keypad. That's going to be under the field bus configuration in the FB parameter group. Those need to match. If the problem is still there, you're still getting the E.bus after switching speed control methods, then it's likely between the keypad and the drive itself. So a few things you can look at there: pop the keypad off, look at the pins, make sure nothing is missing, bent, that type of thing. And then also making sure that your keypad is snapped in properly. Again, you should hear that snap. If you don't, it's not seated properly. Does anybody have any, have you seen this abnormal bus stop occasionally? No? Okay. Yeah, for the most part, you shouldn't see it. If you are seeing it, it's likely due to something going on between the controller and the keypad. Noise, a lot of times if we do see it, that seems to be an issue. Again, you would see that in an intermittent situation. E.EnCC1, error encoder 1. So this error you're only going to get for incremental TTL encoders. Basically just means that you're missing a channel pair or a voltage differential between the channel pairs. So troubleshooting this, you can take your meter, put it to DC voltage, and measure between the A and B channels, and we should be seeing at least 2 volts there. If we're not, something's going on with the encoder. Also, another note with this is that some encoders, they feature a 3rd channel. Sometimes they call it an N channel, Z channel. I've seen O. That is something to be aware of. If they do feature that, and the print indicates that you wired up, then yes, follow the print, wired up. If they don't have that, is what you need to do is you need to jumper out our 3rd track. We call it an N track, but you need to jumper that out on our end. And you can do that. You can take 5 volts from the next terminal strip over on the encoder card, X3B, pin 7, and you would just jumper that to X3A pin 5. That'll give you the N plus channel. It's 5 volts, and then you would just jumper the X3A pin 6 to the common X3A pin 8. So that way, if you measure between those two, the N and the N plus, you should have a 5 volt differential there. On a number of occasions, depending upon how far away your motor is from your drive, I have seen that there's enough of a voltage drop from the power supply on the encoder card to the encoder that the encoder just isn't getting enough power. Most encoders, they seem to be rated around 5 to 30 volts DC for incoming power. And if they're just using our 5 volt supply, if it's long enough, if the encoder is a long ways away, again, you might have just enough of a voltage drop where there's a power issue there. So one thing you can do is we actually have 15 volts available on the encoder card. You can hook up the incoming power for the encoder to that and see if the error goes away. Another note on this, you need to, when you do a motor tune, you might actually get this right away, and you might think, well, I'm doing a motor tune, what difference does it make for the encoder? The channels need to be there all the time. So the drive, when you go to do the tune, is actually looking at that. So I have seen too on a number of occasions that when you go to do the motor tune, you get this error. Again, it likely indicates that you're missing a channel pair. The E.EnCC, error encoder interface, this is going to indicate an issue communication issue between the encoder card and the actual encoder itself. So one thing you can look at, I would expect to see this one on a permanent magnet application. So you would have an NDAT encoder, and with the NDAT encoders, the encoders are communicating serially with the drive, and they're actually providing a status to the drive. So what you can do is go to encoder data and look at LE12, and you should see this position transfer. If you see position transfer, that means that the encoder and the drive, they're talking to each other, everything is normal. If you see something else, then that likely indicates there's a problem. A typical one is that you have the wrong PPR entered in. For the NDAT encoders, it should be 2048. If you've got 1024, that error will show up. Sometimes if you replace the encoder and it hasn't been formatted, you might get this new encoder interface or a data unspecified. I have seen that on a number of applications. Again, we just have to go through a formatting procedure to format the encoder. If you see this, no COM to interface, this could be due to actually having no software on the encoder card itself. We have run into a few situations where, due to ESD, electrostatic discharge, between the card has actually caused the firmware, the software on the encoder card to be wiped clean. If you order an encoder card, you notice it comes in that box with the black foam. That's to protect against ESD. And Yeah, but for whatever reason, either when installing the card, there was just enough of a shock to cause that. So I have seen that. So likely, when you get the no comm to interface, that's what that means. All right, a couple of other encoder issues or other encoder error codes that you might see. The first one, the E.HYB, that basically just means that there's an error on the encoder interface identifier. Just look at your connections. Make sure that everything is connected properly. This one's not too common. I don't see it too often. HYBC, error encoder card changed. If you change your encoder card, you may get this error. In order to fix this, what you would do is just reassert LEO1, the encoder feedback type, and that should take care of the problem. E.br, error low motor current. Prior to every run, the drive is going to send out current to each phase of the motor, and then it's going to look for a certain current value coming back from the motor. And if it sees something it's not expecting, it's going to throw this E.br error. Typically, this E.br error is due to something external. It's on the motor side, could be the contactor. Most of the times when I've seen it, it's usually due to a loose connection, either on the contactor, the UVW terminals on the drive, or actually back in the motor terminal box itself, or one of the connections is pinched on some insulation. That's another common one. If that is the issue, you should see it right away when you go to do a motor learn. If something is that loose, I would expect to see that right away. However, in applications that have been running for a while, as things vibrate, shift around, sometimes the connections do become loose, and you might get this error. If you'd like to check your motor, make sure that the internal windings are okay. You can do a resistance check phase to phase on the motor as well. If you go phase to phase, they should be balanced and low. And then if you go phase to ground, you should be reading in open. Air overspeed. So this means that the car has gone above the contract speed that you've set in the basic setup under US 06. Our level is 110%. Where you would see this a lot of times is when you would roll over into contract speed from XL. If you've got loose control, that could be an issue where you've got just enough overshoot that you cause the overspeed. Another issue could be machine data is incorrect. So it's an actual scaling issue. The drive is trying to go faster than what you have the machine data set up for. So that's one thing you can look at. To check that is what you can do is look at inspection speed. So run the car on inspection, look at your motor speed and your command speed. They should match. If there is a difference there, then that likely indicates you have a scaling problem. A few other notes on this. For serial speed control, the controller is going to write a direct RPM value to the drive. So it's not looking at the machine data. So if you're going to make machine data adjustments or scaling of the serial pattern, that should be done in the controller. But if you are using something like digital or binary speed control, where the drive is in charge of the profile, then yes, you would need to look at making sure that your speeds are set correctly in the drive and your machine data as well. Another area where you might get the EOS is on a permanent magnet application right away when you go to run. You might see like a quick jerk, the shiv moves real quick, and car doesn't really move, but then you get the EOS. That likely indicates that either your motor data is incorrect, your encoder position is incorrect, or your speed control gains could be too high as well, especially if it's an unroped shiv. Analog signal failure. So this error will appear if you're running analog speed control, and basically the analog pattern coming from the controller, the drive hasn't received it in time. That's going to be coming across pins 1 and 2 on terminal strip X2A, and basically, yeah, the drive never saw a speed command from the controller. Serial command speed error, it's going to be much the same as the analog, other than if you're using serial speed control, we haven't received a speed command from the controller in a set amount of time. And again, troubleshooting this, you can look at when you're trying to command a run. If you look at the home screen, you know, if you're not seeing a command speed, then yeah, you're not getting a speed from the controller. If you are getting a command speed, obviously you shouldn't be getting this error. But if for some reason it's coming in and out, you know, that could be due to a communication problem between the controller and the keypad. For serial, if you're wondering the command speed, you can look at the home screen, look at the command speed. That'll be in an RPM value, yes. But if you actually want to see the raw data, what's coming directly from the controller, you can look at the field bus configuration, parameter FB2. That's going to provide an actual raw value. It's not going to have any units on it. That value gets scaled in the drive to correspond to an RPM. But if you want to see what's actually coming across the field bus from the controller, FB02. Speed selection error. So this you'll get when you haven't selected the correct speed for binary or digital or serial binary speed control. This diagnostic screen number 4 will be able to help you out here. You can look at the inputs, making sure that you're getting the right signals coming from the controller. And then also checking the input parameters, making sure that you have them set correctly. So if you're using a binary digital speed control, you need to set the input parameters to speed selection. If they are not set to speed selection, even if you are signaling the correct inputs, you will get this error. Direction selection error. So this basically means that we haven't received a direction on the hardware side, so on terminal strip X2A. In order to initiate a run, the drive must receive a hardware direction. We need that hardware direction. Again, diagnostic screen number 4, that'll be able to tell you if you're getting the correct signals, and then checking your input settings, that you have your input set for direction selection. Drive enable switched off. This actually is not an error. It's more of a status, similar to the base block or the BBL. This usually accompanies an error as well. This simply means that the controller has dropped the enable to the drive. If this is happening, you might see this with a fault. So if you go and look at the fault log, is what you would see is the fault, and then you would see drive enable switched off. So how that would work is the drive would fault, the drive on relay would go low or deactivate. The controller would say, okay, I don't have my DRO, I'm going to drop the enable to the drive, and then the drive will log a drive enable switched off event. If you're just getting a drive enable switched off in the fault log and that's it, there's no faults, then there's something on the controller side that we need to take a look at. Whether it be something in the safety string, brake monitoring, things of that nature. But I definitely have seen that where the drive is not faulting, but you're getting this.